friends, welcome to Organic Chemistry Tutorials. Today I will teach you Riemann Tiemann reaction. So let's begin. This reaction is discovered by the two scientists Riemann and Tiemann. That's why we call this reaction as Riemann Tiemann reaction. This reaction is studied in two ways. One is formylation reaction and another one is carboxylation reaction. We will talk about the formylation reaction first. In this formylation reaction, phenol is converted into orthosalicylaldehyde and parasalicylaldehyde in the presence of CHCl3, which is known as chloroform, and potassium hydroxide, and reaction is followed by acidification. Here you see the CHO group. This CHO group is known as formyl group. This formyl group is attached at the ortho position and para position of the phenol system. That's why we call this reaction as formylation reaction, because formyl group is attached at ortho and para position. Here you see two products are formed, ortho and para. Ortho product is the major product because there is a hydrogen bonding between the hydrogen atom of attached to this OH group and the oxygen atom of this CHO group. So ortho product is the major product and para will be formed as a minor product. Now we will discuss about the carboxylation reaction. This reaction is just same as formylation reaction, but here we will use CCl4, which is known as carbon tetrachloride. Here also we get two products, orthosalicylic acid and parasalicylic acid. Here you see the COOH group. The COOH group is known as carboxyl group. This carboxyl group is substituted at the ortho position and para position. That's why we call this reaction as carboxylation reaction. Here also ortho product will be the major product and para will be the minor product, because there's a hydrogen bonding between the hydrogen atom of the OH group and oxygen atom of this COOH group. Now let us discuss about the mechanism of this formylation reaction and carboxylation reaction separately. First we will talk about the mechanism of formylation reaction. In the formylation reaction, in the first step, this hydrogen atom of the chloroform molecule will be removed by the OH minus, which is a base, and we will get this intermediate. And this intermediate is highly unstable, so this chlorine molecule departs and we will get this dichlorocarbene. It is an electrophile because here you see there are 6 electrons in the carbon valence shell, so it will act as a electrophile of this reaction. Now next move to the second step. In this step, this hydroxide ion first remove the acidic proton of this phenol molecule and we will get this phenoxide ion. Now this phenoxide ion is resonance stabilized by the movement of this negatively charged electrons and these pi electrons, and we will get the second resonating structure. And this resonating structure will act as a nucleophile because this negatively charged carbon is more nucleophilic than this negatively charged oxygen. So it will act as a nucleophile and it will attack to the dichlorocarbene molecule, which is an electrophile. Now we will get this intermediate. In this intermediate you see there is a hydrogen atom which is attached to this carbon atom. Here this negatively charged carbon atom will act as a base and it will remove this hydrogen atom, and we will get this intermediate in which the aromaticity of this ring is again generated. And now in the next step, these chlorine atoms are replaced by the OH group by applying the two molecules of the hydroxide ion. Here the mechanism which is followed is nucleophilic substitution and we will get this intermediate. Here you see there are two OH groups which are present on the same carbon atom. so it is unstable, and here H2O molecule will be removed and we will get the CHO group. Now this CHO group is attached with this phenoxide ion. In the final step, acidification occurs and we will get the orthosalicylaldehyde. This is the whole mechanism of formylation reaction. Now let us move to the mechanism of carboxylation reaction. This is very simple. Here also first the base removes the acidic proton and we get this phenoxide ion. This phenoxide ion is resonance stabilized, and then this negatively charged carbon atom will attack on this CCl4 carbon tetrachloride molecule, and this chlorine atom departs and we will get this intermediate. Again aromaticity of this molecule is generated by moving these pi bond and sigma bond electrons, and we will get this species. Now what happens, the four molecules of hydroxide ion um, will remove this acidic proton first, and then these three chlorine atoms are replaced by the three OH groups by SN2 mechanism, and we will get this intermediate. Here also three OH groups are present on the same carbon atom, so it is unstable, and one molecule of water is removed and we will get COOH group. Now in the final step, acidification occurs and we will get orthosalicylic acid. So this is a whole mechanism which is followed in this Reimer Tiemann reaction. Here the electrophilic aromatic substitution mechanism is followed, because here you see the electrophile is attached to the aromatic ring at ortho position and para position. Thanks for watching this video. Please let me know your comments, and you can also tell me what concepts you specifically want to learn, and that will help me in deciding my future videos. And also subscribe my channel for the latest updates and share it among your friends. Thank you so much.